हेलो एवरीवन। ओके, तो आज हम हार्मोनिक एनालिसिस स्टार्ट करने वाले हैं एंड इन दिस लेक्चर वी विल बी लुकिंग एट द बैकग्राउंड एंड द मोटिवेशन ऑफ हार्मोनिक एनालिसिस। बिना इसे जाने हम कभी हार्मोनिक एनालिसिस अच्छे से नहीं पढ़ पाएंगे। दैट इज़ व्हाट आई थिंक। सो इसलिए आई एम डिवोटिंग दिस लेक्चर टू जस्ट स्टडी द बैकग्राउंड and the motivation. That means what actually led to the birth of harmonic analysis. So let's start. Okay, so सबसे पहले this all starts with the Fourier analysis. Okay, just a second. Okay, so as I said, it starts with Fourier analysis. Okay, so actually in 1807 Fourier came up with a revolutionary idea, and that was that you can express any function in terms of sine and cosine waves. Okay, let me write Fourier's revolutionary idea to express. So he basically told that you can express any function in the form of the sum of sine and cosine waves. So if you have studied Fourier analysis, you must be knowing. So there we basically deal with L1t, where t is nothing but S1, the circle group, and there we study that any function f has this Fourier series representation of the form, these are Fourier coefficients into e raised to the power of iota nt, right, where these an are, let me write this, Fourier coefficients. Okay, so okay, here formally speaking, this idea was shocking at that time. Why? Because उस time पे our functions were not rigorously defined. फंक्शंस डिफाइंड थे पर इतने अच्छे तरीके से नहीं जैसे हम आज जानते हैं. ठीक है, सो फंक्शंस वर नॉट rigorously defined. इसका मीनिंग क्या है, that I will tell you in a while. And the convergence was also unclear. उस टाइम हमें convergence भी नहीं मालूम था. ठीक है, इतने अच्छे से नहीं मालूम था. जैसे आज तो हमें पता है that what do we actually mean by a series converging to a function f, and that is उसका जो sequence of partial sum है, this sequence converges to that function f. Yes or no? And then there are some notions of uniform convergence and pointwise convergence. Okay, so here if I'm writing equal, it basically means this convergence. All right. Okay, now let me come on to this. What do we actually mean by functions not defined? Okay, सो एक्चुअली एट दैट टाइम हमने, एज आई सेड, फंक्शंस डिफाइन किए थे, बट बहुत ही लिमिटेड वे में वी डिफाइन दोज फंक्शंस एक्चुअली. ठीक है, उस टाइम हमें नोशंस ऑफ लाइक जो डिसकंटिन्यूअस फंक्शंस होते हैं हमारे पास, ठीक है, और अदर इरेगुलर फंक्शंस, सो उससे एक्चुअली हम उस टाइम तक फंक्शंस एज फंक्शंस नहीं देखा करते थे. ओके, सो फोरियर की वजह से हमें पता चला कि दैट देयर इज सम लिमिटेशन to the way we look at functions, to the way we look at functions, and there is a need to define functions in a rigorous way. So this is what I meant. Okay, so how functions became rigorous? So basically Fourier forced new concepts to be created. So in 1892 Dirichlet defined functions as arbitrary assignments of values, okay, and introduced the conditions for Fourier convergence. After that, so let me call it A and I have B. After that, Riemann which we have studied in bachelor's, Riemann integration. I'm sure we all must have studied. So he developed integration for highly irregular functions. So as you know, उसमें हमने पढ़ा है, ठीक है, कि how to integrate when we are given some irregular functions. Okay, and see Lebesgue. So this all happened after Fourier's idea came into being. Okay, in 1902 he introduced measure theory, and he made the Fourier theory rigorous. All right, so if we have studied Fourier analysis, we all must be knowing that what happens in it. So basically, इनकी वजह से the 3 points ABC that I have given to you, Fourier analysis or Fourier's idea was justified. Okay, Fourier's idea that you can approximate a function in terms of sines and cosines, so that basically became justifiable, that yes, that is true. And if we have studied Fourier analysis, we must be knowing that there we talk about L1T, जो हम development करते हैं L1T पे करते हैं. There we talk about convolution product. There we see कि यहाँ पे जो that Fourier coefficients जो होते हैं, they are basically translation invariant. Right? I'm so sorry. Okay, so it is basically that function Okay, integration is translation invariant, and Fourier coefficients does not change on shifting a function. Okay, so if I take the origin to be something else, then the Fourier coefficients does not get changed. Okay, shifting of function. Okay, so there we have studied all these notions on L1T. Right, now the idea was, and one more thing. Okay, so integration is translation invariant, so that means, just a second, integral fx dx is integral fx plus a dx. So basically the idea was, can I extend this notion to any arbitrary group, because we know S1 is a group. So mind में this idea comes trivially कि क्या ये एवरी ग्रुप पे, हर एक ग्रुप पे हम इसे एक्सटेंड कर सकते हैं? क्या हर एक ग्रुप पे हम इंटीग्रेशन की बात कर सकते हैं? एंड दिस लेड टू द बर्थ ऑफ हार्मोनिक एनालिसिस, because this mathematician named, okay, so there was a mathematician named Har. So it was the biggest breakthrough that every locally compact Hausdorff group admits a translation invariant measure. So the thing that I needed in order to extend my study was basically a measure. मेरे पास मेजर ही तो नहीं था ताकि मैं अपने जो भी मैं काम कर रही थी ऑन L1T उसे मैं एक्सटेंड कर सकूं टू एनी आर्बिट्ररी ग्रुप. For that I needed a measure which has to be translation invariant. Okay, mu xe must be equal to mu e. So Har came up with this very important result that every locally compact Hausdorff group will admit a translation invariant measure. Okay, and that was known as Har measure. Known as Har measure. Okay, so this all led to the birth of harmonic analysis, that we can actually develop the concept or whatever we do in Fourier analysis to any locally compact Hausdorff group. So here you will see कि जब भी मतलब हम एग्जाम्पल्स देखेंगे उन ग्रुप के जो लोकली कॉम्पैक्ट हाउसडॉर्फ होते हैं, ठीक है, and this is how we will begin with the subject. Okay, so here we end this lecture. Hope you liked it.